Hello, packages, parsers, and programs. A favorite film genre that always entertains is zombies and their menace to our human brains. One guy gets bitten, and soon everyone's sickened, which sounds just like dealing with software supply chains. And so this week we talk with Paul Davis about making security choices that lead to more proactive defenses. Run to the mall and stay tuned for Application Security Weekly.
This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network.
It's the show to learn the latest tools and techniques to understand DevOps, applications, and the cloud. Your trusted source for the latest AppSec news. It's time for Application Security Weekly. Zero trust is clearly the future as threats get faster, quieter, and harder to detect. But implementing it shouldn't disrupt the business. ThreatLocker enforces default deny at execution in a way that remains enterprise-ready, scalable, and operationally clean. Unknown software is stopped cold. Trusted apps stay contained, and drift is locked down across the environment. It's zero trust that works in real enterprises and prepares you for the threats ahead. See why CISOs are adopting it at securityweekly.com/threatlocker. Generative AI is powerful, but it comes with real risks, from prompt injection to data leakage misuse and agentic AI. The OWASP Gen AI Security Project unites a global community of expert practitioners who tackle these challenges every day. Together, they've built practical playbooks, adoption guides, and the OWASP Top 10 for LLMs. Resources any team can apply right now to strengthen AI security. And it doesn't stop there. This is open source, built by practitioners, for practitioners, working together to secure generative AI. Visit securityweekly.com/OWASP to use the playbooks and join the effort to protect tomorrow's intelligence today. This is episode 367, recorded January 26, 2026. That's a lot of 26s. I'm your host, Mike Shima, and I'm here with John Kinsella. Hello, John.
Hi. Been a while, it feels like. Just 1 or 2 weeks and it feels like a year.
It feels like a year, but we're not even quite out of January, so you still have some time to make those New Year's resolutions, and we'll check back in on them.
It's a month from Christmas already.
I know. Speaking of how time flies, Security Weekly listeners can save $100 on their RSAC 2026 All Access Pass. The RSAC conference will take place March 23rd to 26th right here in San Francisco. Come by and say hi. To register using our discount code, visit securityweekly.com/RSAC26 and use the code 56U5 SecWeekly. Hope to see you there. Paul is an experienced IT security executive who works to help CISOs, IT execs, and security teams enhance protection of their software supply chain. Additionally, he advises IT security startups, mentors security leaders, and provides guidance on various IT security trends. Hello, Paul. Thank you for joining us.
There. Hi, it's great to be here. Thank you. Long time. Well.
Long time. Yeah, it's good to have you back. And I know one of the themes is to talk about software supply chains because that's often just where a lot of risk is. And just recently, I think at the top of your mind, perhaps we've had the Shai-Hulud, which at least had a cool name. There was also Crystal Worm, some MCP targets. MongoBleed, I don't know that was necessarily a software supply chain attack, but hey, I think that was one of the last named attacks of 2025. So why not give it some marketing? But I've rattled off a couple names there. As we closed out 2025 and we're looking into 2026, is supply chain any different? Are those attacks different, or have any of them surprised you in some way?
I think we were surprised. In fact, I just came across a recent graph from the Open Software Source Foundation showing the rise in attacks, and it's sort of this nice gentle graph going up, and then it goes zoom straight up, which is kind of freaky to see. But the whole thing is kind of a reality check for a lot of people. It's interesting in that it was a campaign. It wasn't just a one-off, and there are still ways of getting in. So from my perspective, as an advisor and also a SecOps IR malware engineer person, it was kind of fascinating how they changed their focus from being the sort of traditional phishing attacks or, just in social engineering, etc., to actually going after the developer and their infrastructure and their tools, which was kind of scary for me. And I don't think it's going to change. I think, unfortunately, I'm seeing signs now it's going to continue.
Yeah, I think it's going to be hard to say when that will ever end. I say with a long sigh, but I like that aspect of they're not necessarily going after the phishing. They're changing targets. I want to make the conjecture that that's because there's more strong authentication. Let's call it FIDO keys, passkeys, maybe better adoption of 2FA or MFA that's not phishable, and that's why attackers have to change. I may live in the fantasy that that's true. But one of the things that wanted to talk about from an angle here is not just there's always supply chain security. It's that talking about Shai-Hulud, talking about even just if we pull in ransomware, it's sort of like, oh, we got hacked. This is how we got hacked. Let's go back and fix this. What if we just didn't, how do we, rather than saying, how do I stop this from happening again? How do we stop this from happening in the first place? Do we already know what the list is and we just organizations need time, or are we not giving them a very good list of what to do?
Do I get points for the first person to say AI in this point? Okay.
No, please.
So the thing is that as we say, the attackers can try many times, but we only have to get around once for them to get in. And this is a new soft target. I am still meeting the problem of the gap between development and security teams, and so this attacking. They're attacking through like compromising public repos of popular software. We're also seeing the sneaky sort of sleeping attacks, which multi-year campaign where they'll be safe, do nothing, and then all of a sudden turn malicious. And then we see some very targeted attacks. The sort of TTPs include not necessarily doing the ransomware attack, but actually this is what really scares me now for this year is a lot of those attacks, they were just gathering intel. They were gathering tokens and email and identity, user IDs, etc. For me, being paranoid, because I call that part of my job is managing my paranoia, is if somebody's got that data, what are they going to do with it? And if you don't realize you're being compromised, you're going to have a surprise in the middle of the night, because it always is in the middle of the night. But that new attack surface of the developer and their tools, I mean, Shai-Hulud was a worm. It went after infrastructure. It spread. It got in. But you asked if there are tools and techniques. I've spent past 4 months helping teams respond to these incidents and how to find it and hunt it down and upgrade or patch or whatever they have to do. But then that root cause analysis stage comes along and they say, okay, great. I've solved the first stage of the incident. Now I'm going into problem resolution. How do I stop it happening? And there are tools and techniques. I call it a layers defense. We have firewalls for network traffic. We need firewalls for software coming from open source because it's untrusted. And the equivalent of a script kiddie doing a half SYN pack scan across a firewall is the same as somebody doing typo squatting or playing clever games with LLMs to try and create malicious packages that look innocent.
I want to hit on that. I'll come back maybe to that chat about what can individual orgs do, but I want to introduce the idea of we're wasting a lot of developers' time on dealing with so many update this package, as well as maybe they make mistakes with typo squatting. But if we also have to say every developer needs to somehow, one way or another, vet this package, or this package got compromised off of the package management system, they pulled it down. What if instead we did a lot more work on these package, npm.js, PyPy, these areas that are delivering and curating them? Have you had conversations from that way about let's go after where these packages are centralized and figure out better ways to prevent the typo squatting in the first place, or whatever type of technique?
Well, sadly enough, the people who manage those repos, they're facing the same challenge as the people who are using those same software packages. They're being also sneakily attacked. There are always new techniques, flags, or whatever to get around the checks. They're trying to. But the real interesting part about it is when you're building software in a responsible manner for business, whether it's compliance, regulations, just innovative, trusted software, you can't just allow it to be the Wild West. You do need to have a way of controlling what packages, and also because it's better if somebody learns how to use a package and it works really well. Shouldn't other developers in your same team use it? So there is this thing of, hey, if I use a new package, and I've heard many organizations say, well, yes, every time somebody uses a software package that's new, they should get approval. Now, I have a kind of weird perspective on developers. They're hackers as well. I like that. I am a recovering reluctant developer myself, and I like it because I can solve business problems, and I can get the technology to dance the way I want it to dance. I can get it to do things. So great, I come across this new package. Well, the thing is, we don't always know that package we've discovered through whatever is going to work for us. So if I follow the process, I should send a request off to security or to the AppSec team saying, can I use this package? And then I wait. In this world of instant gratification where 15 seconds feels like a lifetime, no, I want to play with it. Okay? And then also say, well, actually, that didn't work. I need to try another package, or this didn't work, or that way, or it has dependencies, or it's broken, or whatever. So you go through this thing of, it's called compliance drift. It was one way to describe it. Well, basically, you start loosening the grips of your software so you can develop software. And then when you find the one you like, then you go and request and say it's an approval. That exposure window where you're playing is exactly where they're attacking. It's exactly. So you need a mechanism now where you can say, okay, look, how can I make that easier? And there's two ways. You can put that software firewall, JFrog has one, curation, right? But that's one thing. The other part of it is I want to turn, and most people don't like this, I want to turn the developer into a security-enabled developer. I want to give them information at their fingertips so that they can actually understand why it's being blocked, why it's being stopped, or what's a recommended switch. I want to enable them to be secure software hackers, if that makes sense. So from my perspective, it works well.
Yeah. Part of that, though, is even just vetting. Like, to my mind, I think I've come down, I think, onto just use the package. Who cares? Because the vetting of it doesn't scale. And what are you actually looking for? And I don't think I would put any, what am I looking for here? Any responsibility on the human to vet specifically this one particular dependency. Now, I'm going to make an exception that this is obviously a backdoor dependency, something like that. You want to detect that if it's been maliciously compromised. Mm-hmm. But I don't know, if I just react and say, nobody's vetting other than we'll keep track of the cruft of CVEs that are popping up on all these dependencies, have I just worried you even more? Am I security unenabling to the developer, but enabling them to actually do their job better, more efficiently?
There is this delicate balance between protecting and allowing. It is complicated. You want to do it. I would say now the easiest way of getting security into a process, whether it's a CI/CD pipeline or anything, is to make it invisible, automate it. Make it so it's there, so they don't have to do anything, and only when there's an exception, bring it in. So I like to set up key criteria. Hey, I want to block malicious packages. I don't think anybody would request an exception to use a malicious package.
Right.
Apart from probably the malware reverse engineer teams that used to work for me in my SecOps team. Then they would have a special policy that would allow them to download only malicious packages. But basically, that ability to sort of put the common, allow them the agility, but also enable the developer to understand why things are going wrong or why they're being blocked or why these are issues, etc. In the end, the developer wants to build software that is good quality, doesn't come back for loads of bug fixes. They want to keep innovating. They want to keep hacking new problems. I want to enable that. So by doing that, by trying to enable the innovation, but also protect them, I suppose it's a bit like being a parent. So the person doesn't have any children. You're trying to guide them down the path to success, but you want to put some guardrails in place. And to be honest, in today's world, we can't run at human speed. We have to run at machine speed. We have to run now because the volume has gone up exponentially, as I said in the charts. And that perspective means you have to have machines starting to get rid of the majority. I'm not saying completely take your hands off the steering wheel, but at least let's get 80% of it like assessed correctly and appropriately. Yeah.
Yeah, and I think talking about where organizations spend time, where I've seen them is the aspect of call it like dependency firewalls, like you mentioned. That's something I've heard recently and I say that within the last maybe 4 or 5 months. I think that maybe the concept has been around a long time, but it seems like very popular. To use the French of the day, that we just want to be. We can download any package, but we're going to have a delay. We're going to have a delay of 1 week, maybe 2 weeks of the latest, because we worry that that's going to be the one that has the malware that's been compromised for some reason. And I can understand the sentiment. It's a reaction to, but I see it very much as a reaction to, we saw how other people got hacked. We don't want to get hacked in that one particular technique. So everybody's going to wait 2 weeks and let the one person get popped and infected rather than like centralize that on the package management. And I don't know, I'm framing the story that way. How do you see that story? Is there a better way we could approach, or a different way to frame that?
So it's interesting. When a malicious package comes out, we don't immediately know it's bad. The community, we go and assess. Now, there is a waiting period. When you get to like 14 days, by 14 days, I think you're about 98% certain that you're not going to let any bad in. Now, that's just malicious. That's ignoring CVEs, which are a whole different game, and they have their own life cycle. But if somebody had just had the ability to block malicious, and anything, say, 2 days old, if anything newer than 2 days, I'm not really getting an innovation, the Shai-Hulud, all these different attacks would have been blocked. It would have been a non-incident. You would have got the deputy CISO, or the CISO gets the phone call in the middle, like, hey, I just heard about this awful attack. And okay, hey, let me check. Call your SOC team. Hey, yeah, we saw somebody trying to download it. We stopped them. We gave them a better
That's a good
version
story.
Through the system. But that immaturity, I think, it gives us breathing space. And it's a bit like an incident. When we have an incident with software, we find out the problem. We then do a triage. We then assess what our mitigating controls, because we know we can't just fix it just like that. They say speed kills. It can be with software as well. If you move too fast, you cause more problems than before, right? So what we do is we look for mitigating controls. We give the developers and our infrastructure team and every breathing space by putting mitigating controls in, whether it's IDSs or firewalls or zoning, doing more strict zero trust. Those sort of tricks give you breathing space. And it's the same with software developers. I want us to protect the developers, but not get in the way of the innovation, because that gets frustrating. As I said, they're clever. If I say no and I block them, and we have had some customers who say, okay, we're cutting off access to all the NPM repos till we find the solution. 2 days later, they're up and running. Large organization, right? They had the solution. But I know that if that developer goes down to Starbucks and downloads the library, and then comes back and starts developing, right? How do we stop that? So it's multi-level security inside that. So you really have to, it's education and enforcement, parent-friendly enforcement, if you could describe it that way.
Yes, I'm hearing everyone throw the meme of nature finds a way. Is basically what you're describing there, is how people pull down dependencies. But there was the firewall I mentioned. The other very common approach I see in orgs is we're just going to have a mirror of our own package repos and package platforms, and everyone pulls down from the mirror, and that way we can at least what you touched on, know who downloaded. Did somebody download this Shai-Hulud infected package? And we have a much quicker answer to say we were exposed, we weren't exposed, versus whoever went over to the local coffee shop and perhaps did a workaround about that. But maybe that's limited to just their laptop rather than a CI/CD system. And that to me feels like the other thing that rather than having one npm, js.org, we have a million different mirrors of that because everybody wants their own, I guess, observability as their own protection. And that, it just feels like I wish we lived in a better world. And I don't know, I want to see, John, too, if there are other approaches you've seen that orgs have tried to help themselves around this in a scalable way, rather than just like both Paul and I are saying, we're not trying to get more people to look at more things manually. We got to scale, but it seems like our menu is limited.
I was looking for a chance to break in here, but didn't want to interrupt. The one of the thoughts I have around this, and I was sort of triggered almost a little bit by in multiple ways by going down to the coffee shop and downloading a package, right? There's certain classes of software engineering organizations that they don't let their developers develop on their laptop. Mm-hmm. They've got like a separate machine in the cloud or like maybe beside their desk, and like it's a hardened sort of, that defense in depth type situation. Does that help or hinder in a situation like this? Because I still see the value of having that firewall as you're talking about it, but does that slow things down at that point if they're already on a hardened machine, or how does that play with that in your mind?
I mean, the hard machines, I have been responsible for building virtual development machines for people in India. They probably hated me because of the latency, but I apologize for them. Please forgive me. But it does help. The thing is you have to work out about whether you're protecting against poisoning your well. Okay? If you let bad packages, you're right, Mike, you need to have a central repo of the packages you use for your applications. Right, Artifactory, well known, but basically the reason is two reasons: is everybody should be going through that, so somebody's not manipulating it, insider attack, and going using packages, etc. And you want to be able to identify where somebody's playing games and that. You need a single point of truth for where this package comes in. Okay, but you also need to make sure that everybody's going through that and then going through the filter so that they can't go direct. John, from this perspective, even if they're on a hardened computer, some of the tricks they do, it's that thing of a lot of the tools we use on the endpoints, the EDRs, etc., are signature-based and they're based upon behaviors and stuff like that. But we're always playing the catch-up game, yeah? Mm-hmm. There's always that window of exposure where did we get the signature out fast enough? There's this new technique. If I can just give us breathing space, and I keep bouncing up and down about this, if I can just take 2 days of breathing space and say, just don't allow this thing in for 2 days. It's a bit, do you allow everybody to download immediately the latest service pack from Microsoft or whatever, or do you have it vetted first before you roll it into your enterprise?
I let Mike do it first.
Okay.
I heard you saying on that, right? And that's a great point. But the other side there is sometimes that service pack has something that we have to get on right now.
Yes.
So is it, I guess it comes down to how do you allow the development team to be able to, I'll say, vote for that?
So that's the trick, is we're allowing them to issue waivers. Request a waiver. Hey, I've got this package. It's malicious, but I rarely need it. Okay. They can within their environment, so not yet another screen, not an email, they can actually go and say, hey, I want a waiver. They put their good excuse why they want to use it, and it goes through to the security team, or if it's copyright, it goes through to legal typically. But the volume is much smaller now because we got rid of the obvious stuff. I don't want to allow malicious. I might want to say, let's not allow 9.9 in for a CVS score. You're developing, you decide you want to do that. I don't want a 9.9. So you put this common criteria in to get rid of the obvious, so all the common stuff. So immediately you're enabling the developer to have access to a safe pool of libraries out in the public world that are going to be stored in the central repo, so requests once use many. But you're also not just saying no. Security has a terrible reputation. The only word we know is no, right? We're not really. We're actually business enablers. We want to actually help the organization build innovative, bleeding edge technology with some safety. And so we listen, and we've got to build those bridges, Yeah,
I think, and part of that is that I do like the idea of enabling just developers can obtain the packages they need and want to use, whether it's to experiment, whether it's to build, whether it's to just bump up because there's a known vuln. And it definitely appeals the aspect of here is a way of just of not having to have manual vetting or just request every single one rather than just have the exception based. Here's one that we know has problems, but we need it for temporarily for some reason. Part of that aspect, though, is how do we know it's bad? And you did bring up some concrete signals, a CVSS score. That's a good one if it's 9.9 or 10. If it's known, obvious backdoors, it's been the Shai-Hulud example, just to go back to that. But then there are other areas of what if the CVSS score is not that fancy 9.9 or 10? Or what if it's old? Or what if it just hasn't been, this is a package that is not getting updated because it's relatively stable, relatively static. And here I'm curious, so that's a lot of preamble to set up. How do we know to be worried? And if I've heard recently in the last couple of months about let's wait a little bit for that time to the settling of the package time. I haven't heard as much about S-BOMs. Has S-BOMs disappeared from this? Is that something that I'm mentioning because it was the wrong solution, or is just everybody talking about LLMs because those are the cooler things to talk about these days?
Go, John. You laughed. I laughed.
From my point of view, let me chime in on that. S-BOMs they were, as I say, the sexy phrase of the year, 2 years ago? Mm-hmm. I'm actually starting to find a bit of a use for them at work from the point of view of when people tell me, oh, you're building this and we don't know what's in it. It's like, well, why don't you go and generate an S-BOM and get back to me? So from a manager point of view, they can have value. But I don't know. I'm curious to hear your point, Paul, and where do we go with this in production?
Okay. So last year I was told that's the year of S-BOM. Guess what? This year is the year of S-BOM. This is like Linux. This is the year of Linux. We're going to get there, right? S-BOMs are mandated in standards, in regulations, as being a proof of what is actually going into production. And so you are required to be able to generate them and attest that it's what's in there. And probably one of the most important things is not just the first level. You need all of them, the transit dependencies, everything that makes up that software. Plus, I'm afraid in today's world, you need all the evidence files. Hey, did it go through a pen test? Did it go through a vulnerability scan? Did it go through user testing? Did we get a change record? Was the acceptance of risk, etc.? All those pieces come into this, what I call like the sort of certified build, the trusted application certificate that says, hey, I know everything that's in this thing. I've got SHA-256 for everything, so my security team knows what the hell's going on and I can confirm. I can also see its life cycle, its genealogy, how it there, and I can also see who said yes to let it out. So the S-BOM is a component that's very, very critical, and it's not going away. The thing I worry about is how, as you said, John, I've written a whole presentation around use cases for S-BOM because people just generate an S-BOM and stick it on the shelf. That's a waste of time for me. I'd rather use an S-BOM and have a point of record that says, this is my single point of truth for this build. If I want to know if it's been hacked or manipulated or changed in production, here's where I can go back to say, has it been changed? Who pushed it? Where's the feature or the PRD that went with it? All those pieces go together to actually prove it. And the S-BOM, I think, is critical. It's also with vulnerabilities. You can have first level vulnerabilities, but you could have vulnerabilities associated with transitive to things, transitive dependencies. So you could have, it's good at the top, but somebody goes and breaks something or hacks it, whatever. But I'd also like to get back to the CVS score. The CVS score is a living score, like a living document. It can change at any time. And you need to have the tools and the mechanisms to alert you when something goes bad, right? You mentioned Mongo Bleed. The Mongo team responded really well and quickly to it, but they had released a package back in October, September time, and multiple versions, and somebody discovered this vulnerability, and all of a sudden it's got a 9.9 score. Now, if you're not watching for that, and then you say, where is it? If you don't have that S-BOM single point of truth, as one might say, right, then you can't tell where it's been deployed. And a lot of people had a lot of pain with Shai-Hulud, just like they did with Log4j, I'm afraid, going back years, right? But basically, knowing where it is and knowing how it's being used is critical, and because then you can start triaging. Oh, this is the paper mache coffee machine. Well, it's not critical, but this is the one that takes orders and does transactions across. That's critical. I need to fix that first. Yeah.
Yeah. And what you're describing, even with the firewall, there's aspects of just being able to more quickly answer, am I affected? Am I impacted by this? If an S-BOM can accelerate that, awesome. Because it's an information point. It of itself, if I can get that phrase out, is not the firewall. It's not what blocks the vuln. It just tells you it's dispositive. We don't have the vuln because we don't have that package, and we have confidence in our S-BOM. There's always that asterisk. Or we have that package over here, and we know that we need to have our other defense in depth that's hopefully protecting us there. Yeah. So I do want to come back. One last thing. I want to harp a little bit just on these package management platforms. And maybe I'll just put it to you, one final question to you this way, Paul, is if you did have a wish, is there one thing that you would love to see all these package management platforms do differently, do better, that could, in the spirit of saving developers time or getting AppSec to, rather than repeat a pattern a million different times, centralize it or focus it once here for these platforms?
This might be a terrible thing to do. I'm going to give a shout out to the NPM team, because when our product blocks it, they actually show the reason it blocks. And I think a call to action for all the other package managers, we need to take that data and show it. But for me, I think what they do is amazing. It is such a community and it's innovative. We've got MCP repos now. We have, IDE plugin repos now, all scaring the living daylights out of me, admittedly, because how do I know whether they're good packages or bad packages, or have they turned bad? So, but I think it's brilliant. But I think we, as the community of security people, we work hand in hand. As soon as they're notified that a package is bad, they remove it. But that window of opportunity, if you don't know it's gone bad and it gets and poisons your trusted source of nice packages you think are innocent, then it's a problem. But I think for them, I think we have to, the relationships between the security companies and them is important. JFrog has a very close partnership with those people, so that we work together, so that when there's been multiple instances where we've found something and gone and alerted our threat intel teams, alerted them before it became a problem, it stopped. But I think that's a big thing for me. But in the end, if I had a wish, it would be to have a mechanism to show a single pipeline going into production from the repo through the development experience, through the CI/CD to production. That would be nice and smooth. And I think that trust is we're getting better at it. But the repo people, I'm thankful that I use them all the time. I program in Python, even though I hate it, and I'm publicly acknowledging it. I love Python and I hate it at the same time. But the PyPy team, brilliant.
Yeah, and to be clear, I'm looking for this in constructive ways, because I know PyPy and npm.js, they've both been pushing for stronger authentication for developers and preventing a lot of those takeovers that get those once trusted packages get laundered through account takeover, et cetera, and suddenly become untrusted. But I tend to have a very long-winded way of setting up those types of questions and describing these things, Paul. That's why at the end of these conversations, I always like to turn it around and just say, hey, dear guest, dear Paul, how would you describe AppSec in 3 words?
I use 4 words.
Because you're cheating.
Okay. Yeah. Well, I'm hacking. Okay. I'd like a lean, mean software production machine. Right. Effective, sharp, focused, runs at machine speed, but also is powerful.
Gotcha. No, and I think of the good packages and bad packages out there. I think from the information you've given us, I think we can attest that you're one of the good packages. So thank you, Paul.
Thank you. Pleasure.
I want to say thank you to John as well. Thank everyone for joining us. We're going to take a quick break now and return with news of the week. Ever feel like your network infrastructure is stuck in the past? Meet Meter, the company reimagining what it means to get and stay online. Meter delivers full-stack networking, wired, wireless, and cellular, all in one seamless, scalable, and secure solution. From hardware design and firmware to software deployment and support, Meter streamlines every part of your network while giving you all the control and transparency you need. Whether you're managing a branch office, retail stores, or a massive data center, Meter gives you performance, reliability, and the visibility you need to stay in control. Thanks to Meter for sponsoring. Go to securityweekly.com/meter to book a demo now. That's securityweekly.com/meter, METER. Welcome back to Application Security Weekly. We just talked with Paul Davis about improving strategies for keeping dependencies secure. I'm your host, Mike Shima. I'm here with John Kinsella, and I've got one more announcement for everyone. Most security conferences talk about threats. Zero Trust World lets you attack them. I assume it's talking about attacking threats and not other security conferences, but we'll leave that aside. From March 4th through 6th in Orlando, Florida, this hands-on cybersecurity event features live hacking labs where you'll break real environments, think like an adversary, and learn how attacks really work. You'll also get expert sessions, real-world case studies, CPE credits, and networking with top practitioners. And the Security Weekly team will be there too. Register today at securityweekly.com/ZTW. That's Z Tango Whiskey for Canadians out there. But John, you're not a Canadian. You're here local in America with me. And we've read a lot of news about AppSec this week, or at least I did. And what do we want to go through here? One is from Project Zero. This was a zero-click exploit for Pixel, and honestly, it's a good article from Natalie Savanovich, who's obviously done great work over many years with Project Zero. And I'm actually want to skip over any of the technical parts because if you don't care about Android, or if you're not securing Android, or if you're not dealing with Android, I think a lot of the subtext of this article, or even the text of this article, can be really relevant to you. And the reason I say that is that a lot of what it focuses on is, let's just say there's a vuln, there's a MacGuffin here, but the discussion is how long it took to find the vuln, how long it took to exploit the vuln. And those are two very interesting dimensions because they're mostly just talking about person weeks and that balance of it took us as the defenders or the researchers this many weeks or this many days to find it. And they even say that, one of the CVEs was found less than a day after reviewing a driver, but it might take an attacker many weeks to exploit it, or they weren't even in the time that they had the attention here on macOS and on Apple systems, they couldn't even exploit it because of some cool compiler flag that was enabled. There's more of those aspects I want to get into, but before I go too far, I want to make sure to bring you into the conversation. And when you see something like this, if I'm talking about those time of defender, attacker, does that resonate with you? Is that something you think about just as you're working with your team building software generally?
Just thinking.
And the reason I asked, to give you some chance to still think, the reason I'm asking is in the previous segment, we were just talking with Paul about like our signals, like how much should we care about a dependency in the sense of, well, here's a CVSS score. And we say 9.9, let's round it up to 10. That's one signal. Here's a known vulnerability. But if we were, exploitability, we didn't talk too much about, is this exploitable path, et cetera. And so I guess part of what I'm sneaking in there is it exploitable, but it's more explicitly about how much do we worry, like, is this hard to exploit, easy to exploit, or is that something that the security folks care about for different reasons?
It's funny, sometimes I really care about that, but for some reason right now I'm with my current environment having a bigger think about it. I usually that's sort of me. I'll say those words which I like and no one else does. It seems CVSS, the whole environmental score, like what's the exploitability of it, is how easy to do it. So usually I would argue, and I have actually in the past for published vulnerabilities, I've argued down saying this is hard to exploit. at the same time, I'm sort of thinking now, like if something, it depends where you are, and if you're on-prem or cloud or big or small, depending on how easy it is, because this is talking about a phone, right? It's a single thing. You're popping up, you're attacking a single phone. I want to come back to the Dolby aspect of it later, but that versus if you're trying to go after a cloud service or some sort of a SaaS, right? The service areas are much bigger, so if the complexity goes up, the chance of your success is going to go down because you're going through load balancers or whatever else. And it's like that complexity is actually sort of a good thing in a way. So that's why I'm sort of like going, yeah, I think if I hear something as complex on a phone that just happened to be handed over to border crossing, let's say, we won't say the country because we're going to be. You can guess.
Yes.
And they're going to do their thing with it, with particularly like some Israeli software. They might have a way of getting through there and go to care about that. Versus if I'm running a SaaS service with 1,000 web servers behind some load balancer and like someone's trying to bang on it, I might not care as much. Does that make sense?
I think it makes sense. And there's an aspect here that since you made that distinction kind of like between the phone versus cloud, one of the things that I really enjoyed about this article is that it highlights on the Apple systems that it was harder, and maybe they would not even been able to successfully exploit this over the long time with more time to research it, with the C code compiled with LLVM with the F-bounds safety. So the bounds safety compiler flag. So I like that because here's one flag that you can turn on and you can basically say, developers, we're going to make your software more secure, your C++ code more secure because of LLVM. But, and here it's a little bit hand wavy. Doing something like that, bound safety does introduce a little bit of runtime checking. So it could slow down. And let's just say I'm going to hand wave what that benchmark is, but let's say there's a 1% CPU overhead. If I assert that that's going to happen on your phone, probably not really noticeable, probably not a big deal as long as it doesn't cause jitter in the music you're listening to. That would obviously be bad. But if I come to you and you're working in a cloud environment and I say, this is going to be a 1% CPU overhead, that's very easily translates to cost. Is that acceptable if I can say, hey, but you're going to protect your users? What is the benefit, or how you do that analysis? Let me say it that way.
It would depend upon the company, right? And how much do you care about security and how much are you willing to secure? In my case, yes, I'd happily spend that. And yeah, those numbers get pretty big, but yeah, that's the thing, right? It's like how, and I think again we should come back to this with which story was it later? The OpenSSL, yeah, about how these performance regressions they might make you more secure, but what happens to the rest of the space? Yeah, and for some companies, that 1% is going to be a huge deal, and they're not going to be able to deal with it.
Yeah, and so before we do move on, you wanted to talk about the Dolby aspect. Tell us why.
So one of the interesting things about this, to talk a little bit about the vuln itself, this is sort of a crazy vuln when you think about it. So Dolby audio encoding on Pixel devices, the vulnerability in there allows people, if you're leaving a message, to compromise it, or leads towards that direction. I'm sort of hand waving here a little bit just to keep going. Dolby UDC, but one of the reasons you went straight to thinking about the defense of this, but on the announcement and patching side, Google told Dolby about this. I just removed my highlight. It was 58 days, I think it was, for them to respond. 54 days. But what I want to talk about is nothing against Dolby. Great stuff. But they are a technical organization, right? The Dolby specs and like how they're implementing amplifiers and cinemas and stuff at home, it's pretty technical. But are they high tech? But is like, are they used to doing like software security and things like that? They're probably thinking a little more about being air gapped in a cinema. But so now you've put this software that they've developed onto a phone, which is that target for people who are, in many cases, being watched. and you've now got something people can attack. So it's similar to me in my mind when we talked a year or two ago about the lock startups that were putting IoT on the lock on the front door of your house, and they had no security experience at all, versus say like Schlag or Yale locks, which like they've been doing locks for centuries, I think. And it's that same thing here. It's like you've got Google. I think you could almost make an argument they have decreased their security exposure, increased their security exposure by partnering with a company that that wasn't one of the top things in their mind. And from a security architecture point of view, that's interesting to me.
What I'll add to that too is that also these decoders that weren't necessary on your Pixel, because you're not running these types of audio formats or video formats on your phone. They're going to hang out with Nicole Kidman in the cinema, because this is where even breakups seem better somehow. I sorry, I flubbed the quote, but forgive me, Nicole. But yes, the point there was talking about attack surface. And the other thing, one little asterisk, the other thing I wanted to focus about time is that, yes, it makes a point about, one of the researchers, Seth, found a CVE after less than 1 day of reviewing a driver. But as the article also points out, there were actually about 3 to 4 weeks of setting up a lot of tooling and analysis to be able to debug and analyze that driver. So there is a lot of work that goes on behind the scenes for this type of research. And since we're talking about research, we'll come back to the OpenSSL in a second for you, John. But I did want to pull in a real quick one, continuing my curl fanboy, apologies. Curl is dropping their bug bounty program. So they're moving away from HackerOne, or as everybody likes to pronounce it the other way. But basically, Daniel Stenberg of the project is saying that there's just too much slop. And the bug bounty is creating that incentive. So people are like, hey, if I can make money off this, I'm going to try to. And they're essentially, to quote, submitting crap and non-well-researched reports. And if we talk about the time factors like we were attacker costs and defender costs in the previous article, or even if we talk a little bit about it with Paul, the attacker costs or the bug bounty researcher costs are very small to run a chat GPT or whatever to say, oh, curls probably has this terrible CVE, CVSS 10.0 flaw in its printf function. And it takes a little bit more time for the curl maintainers to say, well, that one's probably an easy one, with my hyperbole. But in others, it's like, wait, is there an overflow here? Is this reproducible? And no, it's just junk, and it just takes a lot of their time. And time is something that doesn't scale very well for humans. So I thought this was a very positive thing for curl to do. And also to point out, this doesn't mean they're canceling vulnerability disclosure program. They're just not incentivizing it with money. So not sure if there's much more to add there, but I'll give you a chance, and then let's go to the OpenSSL.
Not much more to add. I'm going to do the John come back in 6 months type thing. There's and I think we could tie this in a little bit also to your skills article. I clicked too deep down into it, but where was it coming from?
Trail of
Bits. From the point of view of, as we figure out how to use these LLMs, what does that do to these programs in general? If it becomes, okay, there's a lot of slop. I get that. I get that's the point of this. But as these tools become better to use, will that decrease the value or the interest in these type of systems? A lot of people out there right now are shaking their heads and saying John's crazy, and that might be the case. And also probably what's going on the other side, there's people throwing stuff at this. They're creating this slop because they see in some cases like HackerOne, like, hey, am I going to get either credit out of it or money? And that's where their mind is more so than securing. So maybe that's the right path to go.
Yeah, we will see. It's definitely going to be, we're going to be revisiting LLMs probably every month, if not every week. But, the previous article with Project Zero, that was still very focused on humans and fuzzing, doing that analysis. So LLMs aren't finding everything quite yet, nor do I think they will be. But let's go back to that idea of how humans are developing software. And evaluating software. Now, I think there's probably a joke with developers that everyone else's code always sucks and your code is always great. So that's the classic case where teams inherit projects and they re-implement them from scratch. There's another go-to cliche, as it were, about ever since Heartbleed, it's been pretty easy to pick on OpenSSL. And I don't think that's not necessarily undeserved. But rather than just picking on it for the sake of picking on OpenSSL, I grabbed together an article, one from just this January, the state of OpenSSL for, for Python's cryptography library, and threw in some other articles from last summer from HA Proxy, and even another reference from the curl blog about using HTTP3. But the reason I'm pulling these together is that there's a lot of just complaints about OpenSSL 3 and their APIs either introducing performance regressions, which goes to that aspect of, hey, is 1% more a 1% cost in CPU, a good trade-off for security? That's not what's happening here. But also just let's call it the ergonomics of using an API is terrible. And I think that's one of the things that OpenSSL has struggled with for a very, very, very long time. And I think, before I throw it over to you, John, the reason, to be clear for our AppSec folks, it's not so much talking about OpenSSL specifically here. As always, I like to take an example of an article and then generalize it into the sense of, if you're creating, if you are an AppSec engineering team creating that hardened platform, or you're trying to deliver that paved road, what does the API look like for adoption? And I think that's what the subtext here, what I'm trying to tease out is, if you have a terrible API, but it's for this great secure paved road, ain't nobody going to use it. Or if the performance is bad, people probably aren't going to use it. So there's very important software engineering things to keep in mind, even as security practitioners. So I'll stepping off my soapbox. Let me give you a chance to chat for a while.
Yeah, this article was sort of, it's probably not scary, but scared was probably my first reaction. Just like seeing the size of performance changes by doing some of this stuff. And actually I just passed, I saw that highlighted. They actually have a comparison with boring SSL, which I thought was really interesting, and talking about how one of their encapsulations takes 37 lines with 6 available function calls in OpenSSL. Boring doesn't, in 19 and 3 available, 19 lines and 3 available function calls. So just sort of, I love the openness to look at, hey, what are the other guys doing? And not like, they suck, we rad, like sort of you were talking about before, my code good. But hey, how can we improve by, if there's 2 projects out there, what are they doing that does this better, or we can learn from? The other thought in my head around this, as you were eloquently going through this, is not really is our brains diverge a tiny bit when you're talking about, I can't remember exactly where it was, but you started talking about this project and how they grow and how they improve over time. And my thought was like, sort of similar to, I was thinking through like what other relatively old open source packages are going to start going to start gathering like I don't want to say security debt, but like really in a way, right? No, it's not security debt. As they become more, as their architectures grow to support more and more platforms, right? Like OpenSSL is a little bit like libc from .org. They've taken stuff out, but there's still sort of kitchen sink in there. Does it become harder and harder to secure them? Do you have to take this very refreshing step back and go, we should probably have a serious think about how we're doing this? So I think that's really interesting. How do you do that from a corporate point of view? If you've got a software package which has been around for, I don't know, a decade, or a service, when do you take a step back and go like, we've had a lot of support for our customers, a lot of features. Did we ever think about, do we need to streamline this, or how's it going, or do we have to like do a fork and come up with a brand new version? Or I think that's sort of an interesting thing to think about there.
That is, and just even planning out how do you migrate from one service to another is there's a lot of pain there, because and to that point, one of the things to be interesting, I think this won't be a 6 months later, this might be a 6 years later, but to look at this aspect of complexity in APIs section that you called attention to, okay, OpenSSL, 37 lines, those 6 function calls, would boring in the next 2 or 3 years, it's 19 lines and 3 function calls. Is that going to necessarily increase because of some complexity with back-end memory allocation systems that it's supporting or some other type of platform? And I think those are just important things to track, but those are very helpful ways to compare, and they are pretty straightforward benchmarks. There is taking the emotion out of it of my code cool, your code is not cool, and really just saying what does a good measurement tell us about this to make an informed decision?
It's sort of to think back a little bit about the conversation with Paul. It comes down partially to a strong-willed maintainer, I will say, from the point of view of you have to be, because think, using the boring example, someone's going to come along and go, man, that's awesome. I'd love to get boring SSL ported to my iPhone for blah, 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 blah. And they send in this crazy huge pull request, or maybe they do it over time in smaller chunks, but they've got this drive to bring this code in, and people are like, oh, that'd be great. We want to do that too. And all of a sudden, boring starts growing and growing and growing. And that's sort of, not a bad thing. It's done with good intention, but that's where I think it takes a strong-willed maintainer or a group of maintainers to go, that's not the spirit of this package, or that's not what we want to do, or how we want to do it. We did this from scratch, so hey, maybe if you want that, maybe you go do it too. I'm just completely making this up, but and then you end up with the same thing maybe in 6 years. So yeah, I don't know. Interesting to see.
Well, that's a very helpful setup. So I'm going to segue actually over into an article, What Does It Take to Ship Rust in Safety Critical? And it's talking about safety critical essentially for embedded systems, areas like the automotive industry, areas where safety actually has a definition and actually has maturity levels to it, not just the hand wave of safety that we might just say offhand. Anyway, moving on. The reason I highlighted this is that it was interesting the way you were describing that in the sense of what is the nature of our project? What do we want to expand to? Does this big change to expand into, to support this platform or this other thing, this MacGuffin for my word of the week? Is that in the spirit of our project? Because a lot of this article talks about dependencies. And that was the other reason I pulled it in, because of our conversation with Paul previously, is that one of the things, there are 2 things that stand out. I love the aspect of isolate the highest criticality logic into the smallest surface area you can. And that translates into Android and codecs, audio video codecs, rewrite them into Rust, put those into areas that are least privileged. The Linux kernel is trying to do that with drivers, etc. That's a very pithy, very short phrase that I think applies to much more than just Rust. But if you scroll down near the bottom of this article, it starts talking about dependencies and how a lot of teams, organizations are like, yeah, we have dependencies, but as we go increasing our safety levels, we just start rewriting or trying to rely on as little of those dependencies as possible, because they're either too big, there's too much attack surface there, which they don't really say. They say more there's too much complexity surface, if you will. And we can just rewrite that into the constraints that we need. We don't need, we need maybe, I'm making this up a little bit, we need 2 functions out of this entire, 2 megabyte library. Let's just write those 2 functions. And that to me feels like maybe that's a future where we don't have the multiple thousands of NPM packages on the package management platform, and people, an npm-i does not pull in several hundred dependencies. It pulls in a few, or over time you get rid of a few. That is me and that's my fantasy league of software development. I don't think that will ever happen, but I do like the principle of it. So that's me wishing.
I liked, it's an interesting read, sort of, I would take this article and say, it's a chance to peek inside the mind of people who are doing, some of this really serious software, unlike what let's be honest, what we usually do or talk about. In the, I don't know, probably about the second page on this, they go through some of these standards. So like these things they're talking about are that they are conversing are so defined. There's like an ISO spec 26262, IEC spec, multiple IEC specs for medical or industrial devices, an aerospace spec. What's interesting about them is you can go and sort of, I started doing it earlier today, just like grab one of those guys and search and start understanding like, oh yeah, these guys, like the automotive one, there's like what caught my attention is there's a branch specifically for motorcycle security, or for security for the systems on motorcycles. How do you think about that? And yeah, it's suddenly becomes very real where we frequently go to, well, what if the software is running in an X-ray machine and you might burn somebody. But yeah, if that's on your motorcycle, controlling maybe like a Bosch, they've got a little gyroscope in there, equivalent of, and suddenly that goes sideways and your anti-lock brakes stop working. Now we have a problem. So yeah, it drives home a lot of this stuff that we talk about. And you were asking before about, that 1% cost, probably 10%, 20% cost if it's on that motorcycle. I'd really like you to do it. So I say as a motorcycle rider, but yeah, I think it's grounded this article in the point of view of, and it's probably how they're asking the questions, but it's not so much the big sexy topics we frequently talk about. It's very sort of, this is how we do it in a professional setting to make sure what we do is correct and accurate. So I think that's a nice read.
And I'll pull a real quick parallel too. We had a conversation a couple of weeks ago with Bob Lord and about hack lore, and he pulls in, I thought were very helpful parallels with the automotive industry, the aerospace industry, and not just like the shallow metaphors that too much of AppSec uses, but pointing out that, like you were describing, John, there are actually very well-defined criteria levels, maturity levels, aspects of quality of which security can be a subset of quality, and security just is lacking very similar types of references to do this. If security has something, people will say, oh, we've got the OWASP top 10, for example, or something like OWASP. And I'm using that, as John is laughing, because he knows the segue I'm taking here is to an article from Mark Curphey, titled "The AI Slop Discourse is Missing the Point. Your authoritative," in scare quotes, "security guidance might be worse." And this is, the title describes it well. But his point is, he went and looked at, in particular, the OWASP Go Secure Coding Practices Guide that basically was popular in the sense of lots of GitHub stars. It has the OWASP brand on it. It has... it just looks like it should be something where, hey, we need security awareness training. Go give this to your Go developers. But if you pay attention to it, it hasn't been updated for almost a decade, since 2017. And so what Mark did was, rather than just point out this sucks, he took the constructive approach of look at the ways that it's old, it's out of date, it's missing what the current state of the art is. And he actually had, I think it was Claude, help him rewrite it. So his point is more about, do you just want to have some old stale recommendations that are supposedly part of your security guidance, or do you want to have something that is accurate, relevant, and represents what Go code could or should look like today from a security perspective? And he points out a lot of things that were missing from that, a lot of things that even the Go's security practices that it documents itself weren't even covered in the OWASP documentation. And I thought this was a really insightful aspect in the sense of documentation has to be maintained. Documentation needs to be updated. And we'll get to the AI part in a second, but it really, to my mind, means it needs to be curated by humans for humans to figure out, is this relevant to my work? So those were the things that stood out to me. As you've been pointing out, our brains diverge sometimes, John. I'm curious where your brain went on this one to continue the zombie theme.
Yeah, we were talking a little bit, excuse me, a few different directions. So let's see if I can remember them all. The first one is the openness of OWASP is what allows, I think he said in there, he had Claude scan, 400 projects, 420 something. I closed a tab already some while ago. I lost the tab, so I'm doing this from memory. 400 plus projects on there The reason you've got so many projects is because a ton of them are abandoned, right?
Yeah.
But that is the spirit of OWASP. We want you to come and, hey, if there's a few folks that have an idea about something, let's get together, work on it, see if we can build a standard or a project or what have you. And either we make something amazing or, hey, that was an interesting experiment, and now we're just sort of going to go on about our life. So you're seeing that here, that at some point there was, and I didn't look at the Go project, so I'm not sure how many people are on, but he said there was like 5,000 stars, if I remember right? So it is a thing. But at some point, it lost momentum. And either you had one or two strong drivers that were like just really sort of, as I said before, strong maintainers that were running with it, and then they lost interest, or something happened there. And the thought I was talking with Mike off air was, can we say something here like, is the reason this is now less interesting or less updated, is it less interesting to the AppSec community? Is there something with Go that people are like, oh, it's secure enough? It's sort of memory safe is the phrase I use. It's not memory safe like Rust or some of those other really safe languages, but it does a pretty good job. Got its own runtime environment, not using libc, so it avoids a lot of those type of mistakes. Okay, is that what's going on? Or is it people thinking, oh, this is Google's language, they're going to keep an eye on it, they'll make sure we're safe, so we'll just, let them be the forebearers and we'll just sort of tag along. Or maybe it's not being used by people who care about security as much. Maybe that crowd has gone to Rust. So it's interesting to look at it, to me, from those points of view. I think the one thing he sort of pointed out in the article, which it maybe should be bright red flashing on the website, is this is a what's the status of the project? Begins with an I.
Oh, it's incubator.
Thank you. It's an incubator project. Yeah. So something that's been around for so long, maybe you have after it's incubated, still in incubation for X years, I believe CNCF will pull it if a project is in incubation for too long. So maybe they need to be doing something like that here, or like maybe reach out to the team. I don't know. I think it's sort of unfortunate, but if there's no interest, there's no interest.
Yeah, and I think, and maybe I'll add this too, is that because near the there's a section, what's missing entirely, and Mark has a table of the official Go security practice, and there's half a dozen items on there. Well, maybe I'll offer up as this hypothesis, I'm not sure how we'll test this, is that OWASP secure coding documentation isn't necessary because the Go language, the Go project, introduced its own references anyway. So you don't need that hardening guide. It has within the compiler can give you constructive feedback within the documentation of, and using the language itself. It can tell you how to use Go vuln check, do the fuzzing, having race detectors, etc. And that, to my mind, seems better anyway. And that's a little bit of a callback to why I mentioned that first article from Project Zero. Look at LLVM, turn on that bound safety flag, and your compiler is helping you out. You don't have to go and read through some list. Your compiler is doing something security for you, and you have to figure out, what are the areas where this does protect me, as John says, memory mostly safe or mostly memory safe. What are the areas where I needed to have some follow on? But that feels like the right evolution for me. Just bring all these aspects of lists and recommendations into the language, into the compiler, and leave. Since this was incubator, just let it go away. We don't need another list to be, by the way, if you're writing code, also go over to here and read this, then go back to write code. Just write some code.
It comes back to your old rant around security by default, right? Instead of having to go and get the hardening guide after you install something.
Yes.
Yeah, that did also resonate with me on the Rust article of they were quoting someone saying, hey, we don't have to worry about training our junior developers anymore. Like, we just have them run Clippy and it takes care of it. And it's like, oh, interesting. It makes me, in that case, it made me a little nervous that you're trusting, or you go trust the tool too much? Probably not, but something to keep in mind.
Something to keep in mind. And I did want to, of other things to keep in mind, I did want to sneak in just one, speaking of code safety, Rust, Go, for example, I did pull in one article from Wiz, Code Breach. And this is a long title, Infiltrating the AWS Console Supply Chain. That was why it popped on my radar because we were talking about supply chain this week, and hijacking AWS GitHub repositories via code build. And it's a long title. I'm not taking anything away from articles. It's a wonderful article. Good research as always out of Wiz, but it boils down to a bad regex. Basically, a regex wasn't anchored. And the regex was trying to basically match, are you this particular user? Do you have, does it match this particular string? And because it was an unanchored string, you could match if that string is present anywhere within an input. So if you were looking at the word the, and the word other also contains the in it. So you don't want to match other, you just want to match the. And if you anchor, meaning you start the match at the beginning and the match has to go all the way to the end, that's what you want to see in regexes. And this is easily a decade-old, 2-decade-old type of problem with anything that's using regexes. And what stood out to me was there wasn't a language discussion here. There were a couple of things about, oh, this wasn't as bad as we thought it was. It's interesting in the article. But where was the testing for this that says, hey, here's the test for our regex that says this is matching, our word the, and here's the negative test is matching other that just contains the word the, but shouldn't be in there. And that seems to me a very easy, simple thing, as we're second guessing other people's code for this week, an easy type of test to build that should have and would have caught this type of thing. So feels like a simple mistake, simple way to prevent it. What else would you throw in here, John?
That's a good idea. We can rename this.
Too much.
We can rename this podcast to John and Mike Second Guess People Weekly.
That's right.
Yeah, I don't know. I saw this when it came out. Like those words in the subject catch my attention very quickly nowadays. I'm like, oh, it's that. Okay, whatever. That's fine. I think you did a pretty good job on it. I almost wonder if I think that this is an interesting statement for me, and I'm trying not to be biased here, but we frequently talk about, hey, this is a really good article. It's long and it goes into details and that type of thing. And I scrolled through this. I'm like, is it too long?
Is it too long? Oh no.
And I might be being a little biased there. I'll be honest. I think it is good that it goes into those details and sort of talks through what they're doing. So yeah, I'm just going to go ahead and censor myself and say I probably shouldn't be talking about this one. I don't use the console. I use the console. It doesn't have anything to do with my professional capability or capacity, but yeah.
No, yeah, and that wraps up our news for the week. I did want to throw in, speaking of the hack lore, that was a conversation with Bob about some secure by design, secure by defaults. The hacklore.org website also pointed to some hardening guides, which can be context specific, especially EFF's surveillance self-defense guide. So ssd.eff.org. Very relevant right now. We've been talking a little bit around the events of the week, but if you're in Minnesota, keep your camera going. Check out ssd.eff.org. Keep yourself, your friends protected, and keep the camera going. And with that note, thank you once again for joining us. Thank you, John, as well, for talking through all the news. Please do subscribe. Check out the show notes. Share us on the socials. And I don't have a good segue into my usual synthwave recommendation, but do check out Crawl by Mecha Maiko. We'll see you next time on Application Security Weekly.